What if the biggest engineering project in human history wasn't on land, but across entire oceans? It sounds impossible, yet hidden in plain sight is a question humanity has never fully answered. If we can build bridges across rivers, valleys, and mountains, why not connect entire continents? For thousands of years, bridges have done more than move people. They've changed civilizations. Ancient builders in Greece were constructing bridges over 3,600 years ago. In India, people even grew living bridges from tree roots. Every generation pushed the limits a little further. But here's the strange part. Earth once needed no bridges at all. Hundreds of millions of years ago, every continent was fused into a single supercontinent called Pangaea. No oceans divided us. No massive crossings were required. Then everything changed. Earth's tectonic plates slowly drifted apart. Continents separated. Oceans expanded. And suddenly, humanity found itself living on giant islands divided by vast stretches of water. That separation created a challenge. And humans hate barriers. So we kept building. Bigger, longer, more ambitious. Some ancient bridges are still standing today, surviving nearly 3,000 years of history. They prove something remarkable. Humans rarely accept limits for long. But what happens when the obstacle isn't a river? It's an ocean? Could we build a bridge from New York to London? Australia to Singapore? America to Japan? At first glance, the answer seems obvious. Of course not. But that's not even the craziest part. Because when engineers started looking at the numbers, they discovered something unexpected. Some intercontinental connections might actually be possible. The question wasn't whether we could imagine them. The question was whether humanity could survive the cost. And that's where things start getting weird. Imagine driving from California to Japan without ever boarding a ship or airplane. Sounds incredible, until you realize what it would actually take. A bridge connecting San Francisco to Yokohama would stretch more than 8,000 kilometers across the Pacific Ocean. That's not just long. It's almost beyond comprehension. And this is where it gets weird. Parts of the Pacific Ocean plunge nearly 5,000 meters deep. That means some support structures would need to reach farther downward than many skyscrapers reach upward. To understand the scale, consider the Golden Gate Bridge. It's one of the most famous bridges on Earth, yet it spans only about 1.3 kilometers. Building its foundations required enormous amounts of steel and concrete. Now multiply that challenge thousands of times. The support cables alone could require hundreds of billions of kilograms of steel. The cost? Almost impossible to calculate. But here's the twist. Engineers discovered a route that might be far more realistic. The Bering Strait, a narrow stretch of water separating Russia and Alaska. Instead of crossing an entire ocean, humanity would only need to bridge about 95 kilometers. Suddenly, the impossible started looking possible. Some proposals even suggested a giant railway connecting Asia and North America through this region. But that's when a new problem appeared. Politics. Environmental impact, extreme Arctic weather, dangerous ice, violent storms. Construction crews might need floating platforms and offshore facilities just to survive the conditions. And even if the bridge was completed, would enough people actually use it? That question changes everything. Because building a bridge is one challenge. Making it worth building is another. And the deeper engineers looked, the stranger the economics became. What happens after you build the world's longest bridge? That's the question nobody talks about. Because crossing continents isn't like crossing a river. Imagine driving for days over endless concrete surrounded by nothing but water. No cities, no mountains, no changing scenery, just ocean. And that creates a surprising problem. Human boredom. To keep travelers alive and comfortable, these megabridges would need gas stations, hotels, repair shops, hospitals, emergency services, weather monitoring systems, and constant maintenance. In other words, entire miniature cities floating across the sea. But here's the strange part. The bridge itself might become more expensive to operate than to build. Massive storms could shut sections down without warning. Extreme winds could threaten vehicles. Some engineers even suggest future ocean bridges would need protective coverings just to remain safe. And then comes the biggest twist of all. Most people still wouldn't use them. Flights are faster, cheaper, far more convenient. Even proposed projects connecting Australia to Southeast Asia face the same reality. Despite the engineering possibilities, travelers would likely choose airplanes every time. So after centuries of pushing engineering boundaries, humanity has finally encountered a barrier that technology alone may not solve. Not because we can't build intercontinental bridges, but because they may never make sense. And that flips the entire story upside down. The greatest obstacle isn't physics. It isn't engineering. It isn't even money. It's practicality. For now, oceans remain the planet's ultimate separators. But what if Earth were smaller? What if distances between continents were dramatically reduced? Would bridges suddenly become the future of global travel? Or would humanity discover an even stranger solution? Because the answer to that question might completely change how we think about our world.